Now we're going to look into reading color values from the pixels in our canvas.
We now have a big letter right at the center of our sketch, and the effect we're after is to draw other shapes in the shape of this letter. We can start thinking about this that we're seeing now as just position data and color data. This doesn't even need to be on our sketch. All that we need to know is where we have white pixels and where we have black pixels. We can think of our canvas as a big data map, or a bitmap. Canvas is a bitmap. It is a grid of pixels. When we set the dimensions, we're saying we want this many pixels this way and this many pixels that way. If we get very close to a pixel on our canvas, we see that it is made of 4 channels, R, G, B, and A. Each of these is a number between 0 and 255, which is the color information of the pixel. And color is not the only important thing here. It is also important to know where the pixel is, its X and Y positions, or its column and row on the grid. We already know a thing or two about grids, so that will come in handy here. First, what we need to do is to create a separate canvas for our letter, a smaller one that we're going to use only to read data from. We can create it at the top of our file. Const type canvas equals to document.createElement canvas. And then we also need the context, so const type context equals to type canvas.getContext2D. Then inside the sketch function, but before the render function, because we only need to do this once, we're going to define the grid properties of type canvas. And for that we need width and height, so we can copy these properties here and make them available up here. We know that a pixel is always a square, so we can store its dimensions in a single variable, const cell. We don't need 2 separate values for width and height. And then we can just pick a size for our pixel. Let's say it's going to be 20. And then to find the number of columns, we need to do the inverse of what we did in our previous grid and say math.floor width divided by cell. This means that for every 20 pixels in our main canvas, we're going to have 1 pixel in our type canvas. The width of our sketch is 1080. Dividing by 20, it gives us 54. Then we need to do the same for rows. So math.floor height divided by cell. Num cells is going to be the same as what we did last time, columns times rows. And with that, we can set the dimensions of type canvas. Type canvas width is going to be the number of columns, and height is going to be the number of rows. Now, inside the render function, instead of drawing onto context, we're going to draw onto type context. So just select all occurrences of context and replace by type context. We can get rid of these lines which are commented out, and then replace width by cols and height by rows. And then just to see what we have in here, we can draw type canvas onto our sketch with context.drawImage type canvas and then X and Y 0 and 0. We're not seeing anything yet, so let's try to understand what's going on. An easy way to check if everything is okay with type canvas is to set the background color to black and the text color to white. Now we see a small black square there at the top, but where is our big letter A? The problem is that the font size is now too big. We need to update it based on the size of our new canvas. We could just set it to be the same as the width or the number of columns. And there is our type canvas. Now what we want to do is to read pixel data from it. For that we need a method called getImageData. As parameters, it expects x, y, width and height of the area that we're reading data from. we can store that as a variable called type data and set it to type context dot get image data 0, 0, cols and rows. Let's see what's inside type data using the console. Console.log type data. It's an object of the type image data. It has width, height, and data. And data is a big array with more than 11,000 items in it. That's one item for every channel of every pixel. So RGBA, which is 4 channels, times the width, which is 54, times the height, which is also 54. We already know our width and height, so we can set our type data variable to be just the data property of this object. Now we want to read these pixel values. And we know how to read data from an array. We need a for loop. For I equals 0, I less than num cells, I++. Canvas is a bitmap, and a bitmap is a grid. We already know how to find columns and rows on a grid. So let's do that one more time. Const col equals to I remainder cols. Const row equals to math.floor I divided by cols. Now I want to use x and y, but we already used these as variable names up here, so I'll just rename those to tx and ty. Now the names x and y are available again. Const x equals to col times cell, const y equals to row times cell. Now let's draw a little square for each of these cells. Context.save, context.restore, context.translate x and y, and context.fillRect 0, 0, cell and cell. Everything goes black because we're drawing 54 times 54 black squares onto our sketch. What we want is to change the colors of these squares based on type data. We want to read those RGBA values. Let's create a new variable called R and set it to type data, and in between the square brackets we want the index to be the first channel of the pixel we're at. We know the pixel index. It is the index of our loop, so the letter I. We know that RGBA is 4 channels, so I times 4. And we know that red is the first channel, so plus 0. We don't need to add 0 to anything. I'm just typing it here to make it explicit that we're reading from the first channel. Now to find the other channels, it's very easy. Just duplicate this line, change the variable name to G, and the channel index to 1. Then B and 2, then A and 3. We don't actually need the alpha channel, but we can declare it here. Now we just need to change context.fillStyle and use a template literal this time to compose a single string. Backtick, RGB, open and close parentheses, then $ brackets R, comma, $ brackets G, comma, and $ brackets B. And there we have it. Pixelated version of our big type. This is different from just drawing something small and then scaling up to see it pixelated, because now we can draw any shape we want for each pixel. For example, let's see how this looks with circles instead of squares. Context.beginPath, context.arc, 0, 0, cell, 0, math.pi times 2. And context.fill. That's not quite right. The radius needs to be half of the cell. Now that's almost right. We can see a bit of a margin here to the right and to the bottom of the grid. And that is because the circle is drawn from the center of the cell, but we're only translating to the top left of each cell. So we need to add another translate to cell times 0.5 and cell times 0.5. Now that's aligned correctly.
We're getting there. The real twist comes in the next lesson.